Dr. V.V. Kamesh, Professor of Mechanical Engineering, Aditya Engineering College. Now we would like to find the motion of a link, because there are some links that are moving like this, there are some links moving in this direction, there are some links moving in horizontally rotating direction. Based on the degree of freedom, the link will be having different moments. So velocity at any point with respect to any other point. Basically, we are having the two different motions. One is linear moment and second is rotary moment. Whatever the linear moment we have, that already we discussed earlier in the case of relative velocity method. So if one link is moving like this with velocity, another link is moving with some other velocity, both in the parallel directions, then the relative velocity of one link with the other is very easy to calculate. Now, if the object is having rotary moment, then how to find the velocity of a point on a link or velocity of a link, that means the angular velocity of the link? How we are finding? So, this is based on the configuration diagram. In the configuration diagram, where the velocity will be. So, basically from angular motion in the engineering mechanics, we are having angular motion of a object or a particle. So, when any body, let us take some object, some scale or pen is moving with some fixed length, it is having an object where it is hinged, this is a pin joint here. So, it can move like this. So, in this moment, how the velocity will be calculated? So, when any object is, according to the principles of angular motion, when any body is moving in a circular direction, so the body is moving in a circular direction, the velocity will always be tangential to the radius. Radius of curvature will be r, and the velocity will always be in the radially or tangentially perpendicular direction. So, when this is moving in this direction, so velocity will be at any point. At this point, velocity will be like this. At this point, velocity will be like this. At this point, velocity will be like this. So, the relation between the velocity and r and any other parameter, that we will see now. So, here we are taking one object, a link. This is a link OA. The link is rotating with some angular velocity omega in anticlockwise direction. The radius is OA is equal to r. And we need to identify the relation for VAO with some other parameters. If it is moving to the left side, a small distance, angular distance delta theta in a small time delta t. That means from the diagram, how much distance is travelled? It is A1. So, this is the initial position and this is the second position. So, an infinitesimal time delta t, it is moving an infinitesimal angle theta, delta theta. So, what is the actual theta? This is rotating continuous rotation, it is theta equal to 2 pi. So, we are taking the theta, the small thing delta theta in a small time delta t. Now, what is the velocity we are taking? Actually, the velocity means, the basic definition of velocity is distance by time, or if it is the vector, we are calling displacement by time. Because we are considering to the very small area, these displacement will become infinitesimal displacement and the time will become infinitesimal time. So, not the bigger quantities. Now we are taking displacement A dash. How much displacement it travelled? It is A dash. In what time? It is delta t. So, how this A dash will be calculated? It is equal to r delta theta or r d theta or r into theta, right? So this is a dash will become r delta theta by delta t. This can be written like this, r d theta by dt in the limiting case when in the limits delta t becomes 0. So it will become d theta by dt. It is called omega, that is angular velocity. That's why the VAO is equal to omega into r. This r will be radius of rotation of the link from the standard point or fixed point. This radius will be obviously the length of the link always. Even though you are calling with the radius, radius doesn't mean that there is a fixed center of rotation for all the links. For each and every link, whenever we are calling the rotation of a link, that means where is the starting point? From that, radius means the link of the the length of the link will become radius. So length of the link is equal to the radius. So always we remember the velocity will be equal to omega into r or omega into the length of the link. So these relation will be continuously used many times in the discussion while creating the velocity diagrams, while creating acceleration diagrams. So this is O is the fixed point and A is our starting reference point. So velocity of AO is always perpendicular to the link like this. Now how to get the velocity of a intermediate point B? So this is the long length, very big link. This is the tip. What we calculated till now, the velocity of the tip only we calculated. If we are having any in between point, O, A, another point B here, C here, D here, like this. So we need to calculate the velocity of a intermediate point. So B is the intermediate point and it is to be represented on this OA velocity image or velocity representation on the chart diagram or velocity diagram, where it is having the representation of B. Now we are having the relation velocity is equal to omega into r. That means the link is continuously rotating like this. So for this point, the tip, the omega is the omega of the link given. So the rotation of this point or intermediate point or in between point or any point, omega is constant. When omega is constant, the change in the velocity will be dependent on the change in the radius. That means V is proportional to R only. Here the R is, what is this R? Distance of the point from center of rotation. Here the center of rotation is taken as O. That means if we compare the velocity of VA and VB, velocity of A by velocity of B is equal to the radius of rotation of the A divided by radius of rotation of B. That means what is the radius of rotation of A? It is equal to OA. Radius of rotation of B, it is equal to OB. That means VA by VB is equal to OA by OB. That means whatever the length we are having the selection on the particular link, it depends, the velocity will be dependent on the length it is coming from the standard point or fixed point. If I am taking any other point, some C, so it is dependent on the distance OC. Suppose I am making VC by VA is equal to OC by OA. Like this, the length will be represented and calculated for any point in between. Now, how we are representing this point onto the chart element? How we are representing? So, this is the length OA is taken. Let it be some 60 mm is taken. OA is 60 mm and OB I am taking as some 45 mm. This 60 mm is taken as OA 60 mm. It is representing VAO. For my convenience, these 60 mm can be taken as some 10 mm here. Suppose the chart is not sufficient for me to draw 60 mm. Then what I will do? I will take some scaling. So, based on the scaling, I will put 10 mm to represent this 60 mm. So, I am making by 6. But 45 by 6 I cannot calculate as a fraction and I cannot put here. So, there I need to have some technique. What technique we need to do? So, this AO initially we will draw here. This initially we will take into consideration to consider as O, and this is capital A, this is capital B. Whatever the length we have in the original case, that we will draw in a separated diagram or on the same diagram. Now, this OB equal to 45 we will represent on the diagram. We will join these two and from B we draw a parallel line, then it will become small b. Like this, any intermediate point can be transferred to the chart diagram. Yes. If I am having any small point here, the C, the same C, take the length OC and with the compass you put the point capital C, you draw a parallel line to this, I will get small c. Like this, the same length parameters proportionately can be transferred by means of parallel lines.